Let's start with the homework discussion on quadratics and permutation combination from last class. So I'll open it up. I mean, people can go in any order, doesn't matter. I'll randomly call out. Sarah, you want to start? Which questions you found troublesome?
I couldn't get 1A question 13 right. It's page 49.
Page 49. Thank you for that. Page 49. Question which one?
13.
Question 13. 600 meters of fence, that one?
Yeah.
Is the one? Okay, all right. Let me just paste it. All right, what does the question say? 600 meters of fencing is used to construct 6 blah, blah, blah. Show that the area of each pen is this. Is the first part done or the first part is difficult?
No, the first part is done.
Sorry, Sarah, first part was okay or?
Yeah, I got B wrong and I couldn't figure out why.
So you got A, you're saying?
Yeah.
A was okay, right?
Yeah.
Okay, all right. So I'm not going to do A because it's fairly easy. Find the dimensions of each pen so that it has the maximum possible area. So we must maximize this, correct? So let's say this is your Y or even A, right? Y or A, whatever you want to call it. So we want to maximize this. Now, of course, later we'll study calculus, which helps in maximizing. But in a simple quadratic like this, so we know that it's a downward going quadratic. How do we know that? Because the x square coefficient is negative. So 600 by 9x minus 8 by 9x squared. Correct? So if I have to write it as a quadratic with ax squared plus bx plus c, this is your A, this is your B, and this is your C. Agreed, Sarah? Now, it's an inverted parabola. So the maximum area, so if I'm plotting area in the y direction and x in the x direction, then the vertex coordinates are minus b by 2a and minus d by 4a. So let's apply that. So minus b by 2a would be minus of 600 by 9 upon 2a would be minus 16 by 9. Right? That's your x coordinate. So whatever that simplifies to 600 upon 16, I'm not going to simplify, but that's your x that maximizes your area. Does it make sense? And once you have x, you can find out what y is based on the relation between x and y.
Okay.
Does it make sense, Sarah?
Yeah.
Okay. And what is the area of each pen in this case? Yeah, that's once you find x and y, it's just product. Okay. All right. All right, so let me do this. I mean, some of you might have multiple questions. I'll go in a rotation order. So each guy gets to ask one question in the first round, and then we'll keep going until like all the questions are exhausted. Okay, Thais, what to you? Which question?
It was the question 14.
In the same, the one right after this?
No, in the 1B part.
2 different quadratic equations, that one?
Yeah, I think it was that one.
Yeah, so it is the same 1B that she was also asking right now, right? So can you tell me how the question starts? 2 different quadratic equations. Is that the one? Is this the one?
Yeah, it's this one. Yeah.
Is this one? Okay, all right, let's read this. So 2 different quadratic equations of the form, blah, 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 touch the x-axis. Okay, find the 2 values of k. So for a quadratic to touch the x-axis, which means what? It's like this or like this, right? So either way, the discriminant is 0. When the discriminant is 0, that's when it touches, as in the 2 roots are repeated or coincident roots. Correct? You with me, Thais? Right? So b square minus 4ac in this case is b is minus k. So b square minus 4 into 9 should be equal to 0. So k square equal to whatever, right? 16 into 9, which means k is plus or minus square root of this. So k is plus or minus 12. As simple as that. Does it make sense, guys? So you'll have 9x square plus 12x plus 4 and 9. And let's understand. So 9x square plus 12x plus 4 when k is minus 12, and 9x square minus 12x plus 4. And if you look at each of them, they are perfect squares. So this guy is 3x plus 2 the whole square. and this is 3x minus 2 the whole square. You can see that, which means the two roots in this case are repeated root at x equal to minus 2 by 3. And the two roots in this case are repeated roots at x equal to 2 by 3. When you have repeated roots, that's when you have this tangential type of behavior. Does it make sense, guys? Yeah.
Yes, sir. Yeah.
Okay, cool. Avya, did you try the homework from the quadratic section?
Well,
Or?
I actually missed a message on the homework. So
Okay,
it's
no
like-
problem.
yeah.
What about you, Sumair?
Actually, I had a doubt, but I think it's quite stupid. And
No, it's
one,
fine. No problem at all. Yeah, go ahead, please.
1A question 12, how like 12A.
Find the values of m for which this has a repeated
Yeah,
root, that one.
I just forgot how to do it.
Okay,
Refresh. Yeah.
okay, yeah. So as we just saw, right, repeated root means what? The discriminant is 0. That's in the problem that we just did. It was repeated root. The two roots were repeating. So the repeated root is essentially discriminant equal to 0, exactly same as what we just did. And distinct roots is d greater than 0. No real roots is discriminant is less than 0. So if you have to do the, let me do the second part here, because rather than equality, let me do the inequality. Two distinct roots. Is that okay, Sumair?
Awesome.
Yeah, so b square would be minus 3 whole square minus 4 into 2 into m. That will be 4ac. Suppose we want that to be greater than 0. Then we want 9 minus 8m to be greater than 0. I can take 8m to this side and write it as this way, right? And therefore m is less than 9 by 8. In this case, there won't be any inequality. It'll just be m equal to 9 by 8. And this will work out to be the other direction. M is greater than 9 by 8.
Oh, okay.
As simple as that.
So just D is just B square minus 4AC, right?
Exactly. B square minus 4ac. Yeah. Yeah. Okay. Dev, over to you. Your video is still off, Dev. Or did you message me that you're out or something? Or I'm not sure. Okay. Yeah, I can see you now. Any questions, Dev?
So question 8,
In
1A.
1a. The roots of are alpha and beta. Find the roots. Find the equation which has 1 by alpha and 1 by beta. That one.
Yeah.
Okay, let me just paste it clearly. It didn't come out well. Okay, so this again should be straightforward. I'll do it, but I'll have to question all of you guys. Some of the easy questions I don't want to necessarily discuss because you should have been able to get this. But anyway, I'll do it once, right? So roots are alpha and beta in the original equation. So which means you know the sum of roots is alpha plus beta, which is minus b by a, which is minus. So I'll write it as 2x square. Okay, I'll write 2x square minus 3x minus 4 equal to 0. So minus b by a is 3 by 2. Agreed, Dev?
Yeah.
And the product of roots is alpha beta, which is c by a, which is minus 4 by 2, which is minus 2. Right? So this is for the original equation. Now you're searching for a new equation. I'll do that in red. So this is a new equation. So the new equation has roots as 1 by alpha and 1 by beta. So the new sum, let me put it as S dash, is 1 by alpha plus 1 by beta, which is, if I take common denominator as alpha beta, it's beta plus alpha. And we know what the alpha plus beta is from the previous step. It's 3 by 2 from here. And we know alpha beta also from the previous step. It's minus 2. Therefore, the new sum is minus 3 by 4. You're with me, Dev?
Yeah.
And the new product is 1 by alpha into 1 by beta, which is 1 by alpha beta, which is 1 by minus 2 or minus 1 by 2. And now, once we have the sum and product, we know the general rule is x square minus sum of roots into x. This is not power, it's just a dash, a hyphen, right? Maybe I'll just mark as S star so that it's clear. It's not power or something, right? So sum of roots x square minus sum of roots times x plus product of roots equal to 0. So that's the general equation in terms of the sum and product of roots. And now you just have to substitute S star is what? Minus 3 by 4. Therefore, it becomes plus 3 by 4 here. And then P star is minus half. So it's just this. Now I can leave it here. I can optionally multiply it by 4 so that there's no fraction in the I can leave it like this also. Either way is fine. Even this step is fine technically. Does it make sense, Dev?
Yeah. Thank you.
Yeah. All right, Keshav.
No doubts.
No doubts. Excellent. Love you. Okay, Moksh.
I've got a doubt with question 12 in review set 1C.
Question 12. Okay,
Review set 1C.
1C. Okay, I'll go down there. Question 12. Okay, this is the one. Ax square plus 3 minus a times x.
Yeah. That's
Okay.
it.
Okay, has roots which are real and positive. Okay, so important things, right? So the two roots alpha and beta, alpha is greater than 0 and beta is greater than 0, and both are real. Okay, he doesn't say the roots are repeated roots or not. They may be repeated roots, they need not be repeated roots. Okay, now if both alpha and beta are greater than 0, right? What does it mean? It means the sum, which is alpha plus beta, should be greater than 0, right? But the product also has to be greater than 0. Only then, okay, forget quadratics. Just forget quadratics. Just think of two numbers, right? If
Can't we
two
just
numbers,
use discriminant?
sorry, say that again.
Can't we use the discriminant?
We can use the discriminant also, but it's easier in terms of sum and product of roots again. We can use discriminant also, but we want two roots. Okay, forget the quadratic again. Let's think of just numbers. If we have two positive numbers, then what can we say? The sum is also positive, the product is also positive. That's the property of two positive numbers. Whereas if let's say one of them is positive, one of them is negative, the sum might be positive, but the product will be negative. On the other hand, if both are negative, the sum will be negative, but the product will be positive. So the only combination where the sum as well as the product are positive will be when both the roots are positive. Does it make sense? Moksh, you're in agreement? Yeah, sorry, I didn't hear you fully, Moksh. You are in agreement?
That makes sense. That makes
Yeah,
sense.
okay. So in other words, the condition is the sum must be positive, the product must be positive. Let's bring in both conditions here. So the sum must be positive. So what do you mean? The sum is minus b by a. So in this case, minus of 3 minus a by a. That must be positive. We'll solve this separately. The product must be positive, which is c by a. Minus 4 by a must be positive. Okay, so far so good. Let's solve these two conditions separately and then we'll put it together. But so far, is it clear? Are we in agreement? Sarah, does it make sense why sum and product both have to be positive? Only then the two roots are positive. Okay, now how do you solve this type of questions? So I think I've touched on it briefly. Look at the numerator and denominator independently. What are the values of the variable, in this case a, in this right? A is technically a constant, but as far as this inequality is concerned, it's a variable. When will the numerator be 0? When a equal to 3. So mark 3 here on the number line somewhere. Where will the denominator be 0, or any expression in the denominator will be 0 at a equal to 0. Okay, so 0 and 3 are the two critical points as far as this inequality is concerned. This method is called the sign test. Sign test. Right now, let's take a number which is, so the 2 points 0 and 3, divide the number line into 3 parts. Left of 0, between 0 and 3, and to the right of 3. Okay, now let's take a number to the left of 0. Let's start from the left, right? Let's say a number like minus 1, doesn't matter, any number, right? If I put a equal to minus 1, what is the numerator? Minus of 3 minus 1, which is 4, upon a, which is minus 1. So effectively it's positive. So the entire quantity is positive here, right? And generally, when you have a boundary like this, it'll flip sign as you cross each boundary. But let's verify that. Now I'm in the second region between 0 and 3. Let's say a equal to 1. So the numerator would be minus of 3 minus 1, which is minus 2, upon a is 1. Sure enough, it's negative. So in this region, it's negative. And let's take a number in the third region to the right of 3. Let's say a equal to 5. Then we have minus of 3 minus 5, which is minus of minus 2, which is 2 upon 5, which is greater than 0. Right? So the values of A that cause the sum be greater than 0, which is what we want, is A should be less than 0 or A should be greater than 3. You with me so far, Moksh? Okay, now let's come to the product. The product is much easier here because it's just -4 by A. Ratio of a negative number to another number should be greater than 0 means what? A must also, only a negative upon negative is positive. So A must be simply negative, that's it. A should be less than 0. Okay, now we have two conditions now, and both must. So this and this. Okay, so
A has to be less than 0.
so exactly the intersection of both of them. So the first part is saying I'm okay with A less than 0 or A greater than 3. Second part is saying A should be definitely less than 0. The intersection of these two is just A less than 0. Does it make sense?
Is that the answer, sir?
Yeah, hopefully this should be the answer. If it's
So
not,
that does match what's in the back of the textbook. Right?
oh, does not match, then they must have done something wrong. Is that what you got as well? Is this what you got as well?
No, sir, I got another answer.
Okay, what is the answer at the back for this one?
Let me check, sir. It's just loading for me.
C by A. Both are real. Oh, okay. Maybe I'm missing one more condition. Yeah, both are real as well, right? So we are never. So for them to be real, the discriminant must be greater than 0 as well. So that is another condition. So third condition, right?
Yeah.
So the discriminant must be greater than 0. So the discriminant is B square minus 4AC. So minus of -4, which is 16A. Right? Do you agree this is the discriminant? This must be greater than 0. So let's simplify this. This is A square minus 6A plus 9 plus 16A greater than 0, which means A square plus 10A plus 9 is greater than 0. Now I can simplify this as A plus 1A and then, sorry, A plus 1 into A plus 9. We can factorize this fairly easily, right?
Yeah.
A plus 1 times A plus 9, right? Which means how do we get this inequality? I mean, how do we solve this inequality? So suppose this were to be an equality, right? And suppose we are solving the equation A square plus 10A plus 9 equal to 0. The two roots would be at -1 and -9, -1 and -9. So this quadratic in A, right? Let's say A is the x-axis, right? This quadratic in A would cut the horizontal axis at -1 and -9. All of you with me? Sumar, you with me? Okay. Now we want this product to be not equal to 0, but greater than 0, which means we are looking at this region or we are looking at this region, which means we are saying A must be greater than -1 or A must be less than -9. Only when A is greater than -1 or A is less than -9 is the discriminant positive.
Got it,
Right?
got it.
Now putting together all of this, now between these two conditions, we summarize these two conditions as A less than 0. Now we have to combine with this another condition, right? That A less than 0, but within A less than 0 itself, I'll take it if A is greater than -1 or A is less than -9, but not in between -1 and -9. So I can summarize this and say, I'm okay with -1 less than A less than 0. I'm also okay with A less than -9. Does this match the answer at the back? It does.
Yeah. it
Okay,
does,
good.
it does.
Okay, good that you told. Otherwise, I would have not realized this mistake. But it's a good one. Good problem. Does this make sense to everyone? It's worth discussing again if it's not clear. Keshav, you got this?
Yeah.
Okay, excellent. But does this discussion make sense, all of you guys? Abhi, are you with me completely? Okay, cool. Anyone ties? Okay, both conditions are clear, right? Okay, cool. Okay, let's go back to Sarah now. I mean, it's not like to say that each person gets only 2 or 3 questions, but I want to give everyone a chance. So, Sarah, over to you again. Any other question?
No, they're all answered.
They're all answered as part of the other discussions as well. Okay, Thais.
No, sir, you answered all the questions I had trouble with.
Excellent. Cool. Avya, you said you didn't try. So, Sumer, you had any other question?
I'm good, sir.
You're good. Okay. Dev. Okay.
I was fine at them.
Okay. Moksh. I think Moksh, you had one or two, if I remember. You were chatting me earlier.
Yeah, so I reviewed all of them and I got them. My mistakes.
Oh, okay. After you sent it to me, you got it, is it? Is that right, Moksh?
Yes, that's correct,
Okay.
that's correct.
All right. Any other questions on permutation, combination, or any of the stuff that we went over last class? All of you good on that? Okay. Any other doubts? Okay. Okay. All right. So if nothing else, we can start with concept of functions. Okay. So yeah, video is off for some people. Moksh, please turn it on. Okay. I mean, occasionally for 30 seconds and all, it's okay. But if you're going to be on video off for a while, please message me or let me know. Okay. All right. So there's a small difference between a relation and a function. So let's understand what a relation is versus a function. So both are a mapping connecting an independent variable to a dependent variable. So you have typically X is your independent variable and your Y is your dependent variable, right? And then you write a function or relation as something like Y equal to F of X or G of X or H of X. Typically, these are the letters that are used to represent a function. Okay, so a relation and a function, right? So a relation is where you don't care whether it's a one-to-one or one-to-many or many-to-one or many-to-many. All of them are relations. So for example, let's say this is, okay, so this is my X and this is my Y. Okay, so let's plot a few different types of relations. So suppose my graph is something like this. Okay, now for every X, you have a unique Y, right? So this is my X, so this is my X, and this is my Y. Okay, so this is one-to-one. Okay, so for every X, there's only one Y, and for every Y, there's only one X. So it's one-to-one. So suppose I have something like this. Okay, now this is many-to-one, many-to-one. So many X correspond to a single value of Y. For example, this particular value of Y is attained at a few different values of X, namely this value of X, this value of X, this value of X, right? So this is called a many-to-one. Okay, and one-to-many is, so one-to-many is something like this, right? So for a given value of X, I have multiple values of Y, which is why it's one-to-many. You always start with X and then go to Y. For a given one X, you have many Ys, hence the name one-to-many. And then you can have something like a circle or an ellipse, which is for a given Y value, I have two different X values, right? And for a given X value, I have two different Y values. So it's a many-to-many. Okay, many-to-many, right? So what is a function? So the top row is a function where the Y has to be only one. It could be either one-to-one or many-to-one. That doesn't matter, but the Y has to be one. So this is a function, whereas this is not a function. Not a function, right? But all of them are relations. So a function, you can think of it as a subset of relation. All of them are relations. Relation is, as a simple naive English word says, it's a relationship between an independent variable X and a dependent variable Y, right? And if the relationship is such that it's one-to-one or many-to-one, such a relationship is called a function, right? A subset of all possible relationships is a functions, right? Which is one-to-one or many-to-one. Okay, now for any function or relation, doesn't matter. We talk about two things. One is domain, one is range. Okay, so domain is all possible values of X, right? All possible values of X determine your domain. Okay, and then all possible values of Y for those corresponding values of X that are allowed form your range. right? So it could differ depending on function to function. So for example, suppose y equal to, let's say simple root of x minus 2, right? So for us to be able to take a square root, we know that the stuff within the root must be non-negative. So the domain would be x should be greater than or equal to 2, right? And the range in this case would be, okay, suppose x is greater than or equal to 2, then under the extreme conditions, if you just look, most of the functions are monotonic, right? Meaning the extreme values of x will also determine the extreme values of y, but not always that's the case, right? So you have to be careful. But in the simple example, let's say x happens to be 2, then y is 0. And as x increases, y steadily increases. And because it's square root, we have discussed many times, square root stands for the positive square root. So the range would be all y which are greater than or equal to 0. Okay, so that's the range, right? R. Okay, so suppose let's do another example. Yeah, Moksh, you have a question? Yeah, go ahead.
So question.
Yes.
What if, can you find the domain and range of a relation? For example, if you have the relation y squared, is y squared equals x minus 2 a relation or a function? I'm not sure.
Okay, suppose, okay, let's discuss this. So y square equal to, I'll write it here. Y square equal to
X minus 2.
x minus 2. Okay, so if it's y equal to x, y equal to, suppose it is instead of suppose x and y are swapped, or y equal to x square minus 2, or y, then it's clearly a quadratic, right? Which is going up like this.
Yeah.
Right?
But if
Now,
y
this
squared equals
case, exactly. So this will be a horizontal parabola. So it'll be something like this, right? Right. So for example, it's defined only when x is greater than, right? So only when x is greater than 2, this is defined.
so, but this is a relation.
This
So
is a
like,
relation. This is a relation. Yeah. And for this
so
relation also, we can say what the domain is. So we can say the domain is, in this case, x should be greater than or equal to 2. And you can say the range for this is y can be negative infinity to positive infinity. So all real numbers.
just clarifying because
Yeah. That's a good question. Yeah, it's a, so your question is, in other words, for a range, can we still talk about domain? For a relation, can we still talk about domain and range? Yes, we can. All right, it's the same idea. What are the possible x values? What are the possible y values? It's a different thing that for one given x value, there are 2 y values, but we can still talk about the allowed x values and the allowed y values. Okay, cool. All right, so let's do another one. Sorry, I did not have to erase this, but it's fine. Okay, let's focus on functions for now. That's the most important rather than relation, right? So suppose I have y equal to, maybe I'll make up another one, right? 1 by log x minus 3. Okay, log x. This is log x. Okay. Can you guys find the domain for this? I'll just give you maybe around 30 seconds. And if I don't write a base, the default base is understood to be 10, right? We know that. Okay, Keshav, you want to take this? What will the domain for this be?
All it'll just be all from x is greater than 0 and won't be, and x won't be equal to 1000.
Excellent. Yeah. So the second part was the difficult one to get. First part, okay, log x. For log x to be defined, the plain log we know, right? It'll accept only positive values of x, which is why he started off with x greater than 0. Then he saw that log x minus 3 is in the denominator. We don't want to cause the denominator to be 0, right? Now he back worked and found out what will cause the denominator to be 0. So log x minus 3 should be 0, which means what will cause log x to be equal to 3? X has to be 10 power 3, which is 1000. That's exactly what you don't want. So the domain should be x greater than 0, x not equal to 1000. Very good. Okay. Dave, what will the range for this one be? For the same question?
One second.
All of you work out. Maybe give you 30 seconds to think of the range.
Y is greater than minus 1/3.
Y is greater than
Minus 1/3.
minus 1/4. You said, I didn't hear you fully.
Minus 1/3.
Minus 1/3. Okay. Tell me, I'm not saying it's right or wrong. Tell me why. Please, can you explain?
Okay, so first of all, x is greater than 0, so it cannot like have a y-intercept. So from the base value where x is 0, therefore it would be minus 1/3. Like anything greater than that should be part of the graph.
Not very clear. X should be greater than 0. That part is clear. Okay. And so why? So we have log x here, not x, right? So
Yeah. Okay.
I'm not clear of your inference. Okay. Anyone else wants to try? Moksh, you want to try?
So I'm pretty sure R has to be a real number.
Sorry?
Negative infinity to positive infinity.
Negative infinity to positive infinity. Can you explain why?
Like Dave said, x has to be greater than 0, that's true. But log x does not have to be greater than 0. For the logarithm function, anything below, like it can be negative and positive, even if x is restricted to be greater than 0. So the value of denominator can be any real number, and therefore the value of the whole 1 upon denominator can be any real number.
Yeah. Almost right, but yes. Right. So if you look at log x, so maybe what we can do is we can start to mentally, not mentally, we can start to sketch different values of x and different values of y, right? So x can be, let's start from a large value of x where there's no problem at all. Suppose x is a zillion, right? Whatever, right? I'm writing some big number. So log x will be a huge number, correct? Log x will be a huge number. And then therefore 1 upon a huge number, which means y is approaching 0, right? Y is 0, but something positive. Let's say positive 0.0001, something, right? Now x comes gradually close to 1000. 1000 is forbidden, right? I won't take 1000, but I'm okay with 1001. I'm also okay with 999. Now let's generally, whatever is forbidden, you want to test out what happens aju baju, right? Nearby, what happens, right? So suppose x is 1001. I'm just making up a number which is very close to 1000. Then log x will be approximately 3.0001 something, right? I don't care the exact number, but all I want to emphasize is log of 1001. Sorry, I'm just scribbling here too much. Must be understandable, right? So log of 1001 is a number which is very close to 3, but slightly more than 3, which means the denominator will be a slight positive quantity, right? Which means the entire quantity y would be as close to an infinity as possible. So almost like a plus zillion. Does it make sense? Does it make sense to everyone? Dave, you're with me?
Yeah, I guess I understood.
Okay. And suppose it's slightly less than 1000. Suppose it's 999, right? You don't need a calculator for this. You know that it's slightly less than 3. That's all you need to know. Suppose it's 2.999, this, right? By as close to 1000 as possible, then this will be more decimals. And therefore, the denominator will be a slight negative quantity. And therefore, this whole thing will blow up to positive infinity. So right near 1000 itself, on either side of 1000, you have a huge swing possible from positive to negative. infinity, right? And you have the entire range from 0.001 all the way till plus infinity going here. If x varies from infinity to 1001, right? As x varies from infinity to 1001, as long as we are operating to the right of 1000, the denominator varies from infinity to almost 0, and therefore you have all the range of values from 0 to infinity. Right now we have crossed the boundary, we have come to 999, right? At 999, the denominator is very small negative quantity, therefore we have the entire fraction is a huge negative quantity. And then we can go all the way till 0. X cannot be 0, but x can be 0.0001. If x is 0.0001, then log x is like negative infinity, right? So negative infinity almost. So the denominator is a negative quantity, but a negative large quantity, which means it will be all the way till -0 almost. So which means we have the entire range of negative, the entire range of positive, all covered. Therefore, the range of this is -infinity to +infinity. I know it might not be super clear, but that is how it is. Like for functions, to figure out the range, there's no cookie cutter method. Yes, Moksh, go ahead.
I think we were both wrong. 0 is impossible. Like it's -infinity to positive infinity without 0.
Without 0, yeah, that's a good point. Yes, y cannot be equal to 0. That's right, I forgot to include that. Because for y to be 0, then the denominator must be infinity, which is never possible. So you can never reach infinity, which is why here also you put -infinity less than y less than infinity. You cannot reach infinity. And because you cannot reach infinity in the denominator, you cannot achieve 0 as the y value as well. Okay, we'll do a few more examples, it'll become clearer. So don't worry too much if you didn't fully get this. Okay, so I want to cover the concept of domain and range. Okay, that's the main thing. Now let's do composite functions, right? So composite functions are a function of a function. So you can talk about let's say f of x equal to 2x plus 3. Okay, and let's say g of x is ln of x minus 1. ln of x minus 1. Now there's two composite functions. One is FOG of x, which means it's f of g of x. Since it's too much to write, people just write it as FOG of x, fog of x. So what is this in this case? F of the inner function is ln of x minus 1. Okay, now f itself is a function. What does it do? Whatever input comes to f knows to double that input and add 3. So the input itself is ln of x minus 1, but f will take any input, will double it and add 3. So f of this would become 2 times ln of x minus 1 plus 3. Does it make sense, Avya? Does it make sense? By g of f of g? Okay, and g of f of x is exactly similar. It will be g of f of x. So first we evaluate f, which we know is 2x plus 3. Now we pass it on to ln of x minus 1. So the g function knows whatever input comes, subtract 1 and take ln on it. So we'll just do ln of 2x plus 3 minus 1. Because that's what g of x knows to do. Whatever input comes, subtract 1, then take ln, which simplifies to ln of 2x plus 2. Does it make sense? Okay. Now, the problem comes when you have a composite set of functions, and then you want to look at domain and range of the whole thing. So for example, let me just come up with an example here. One sec, I had one here. Okay, all right. Let's say f of x is root of x minus 1, and g of x is log 2, log to the base 2 of x. Okay, now let's understand what each of them separately is. So suppose I look at f separately, the domain is very simple, right? X has to be greater than or equal to 1, because you don't want negative number in the root. Therefore, x is greater than or equal to 1. And suppose you want to look at g separately, the domain is x has to be a positive quantity. Okay, but now let's look at f of g of x. So suppose I'm looking at f of g of x. What does it mean? F of g of x, well, writing you put f first, but technically if you just imagine like a factory, your x comes here, the first bucket it passes through is g, right? So because this is f of g of x, right? So you let x pass through the factory called g. The output of that, which is g of x, you pass it through f. And then this is your final output. Okay. Now, suppose now you can put this whole thing within a block, right? So this is the block which is f of g of x, f of g of x, right? You have a main input x that comes out and the final y which comes out here. Now this is your f of g of x, f of g of x. Okay. Now, as far as g is concerned, it'll accept anything which is greater than 0. If you just look at this guy, log of 0.1 is also okay, log of 1.2 is okay, log of 1 is okay, log of 2 is okay, log of 10 is okay. As long as x is greater than 0, it's fine, right? But just because the x is passing through g, it doesn't mean the domain for f of g of x will be the same as the domain for g. Okay, I'll repeat again. Just because the first block that x passes through is g, we cannot conclude that the domain for this entire block is the same domain as g's domain. Why? Because for certain values of allowed values of g, right? So g allows all the values of x which are greater than 0. But the output of g might not be an input that f can take. Okay, Thais, you have a question? Go ahead.
Yes, sir. I had problems with my Wi-Fi. Could you
Okay.
just tell me what the FOG means?
Oh, okay. FOG means f of g of x. So this stands for f of g of x. So maybe you missed for, you let x pass through g, and then the output of that is g of x. You take that as an input to your f. That's your f of g of x, written for short as FOG of x.
Okay, thank you.
Right? And what I'm saying here is, suppose we have an example where f is so-and-so and g is so-and-so, and then we have a certain domain for f and certain domain for g that we have figured out. Now, if I'm looking at what is the domain for FOG of x, it is not trivial. So why is it not trivial? Because x passes through g, so it's tempting to say that the domain is all possible values of x that g will allow, which is x greater than 0 in this example. But that's not the case, because there are some output values coming out of g, namely g of x, which might not be valid inputs for f. What do I mean by that? So let's take an example. We'll take an example. Suppose x is, I don't know, 1/4. Okay, suppose x is 1/4 or 1/8, let's say 1/8. I don't want too many 2's also, right? Suppose x is 1/8. Okay, so what is log of 1/8 to the base 2? It is -3, right? Okay, suppose we can do that on the side just to recap. Suppose I want to figure out what this number is, right? Suppose I'll just call it p. Then 2 power p is 1/8. And then we know this is 2 power -3 is 2 power p, therefore p is -3. That's how we infer, right? So log of 1/8 to the base 2 is -3. So suppose we let x equal to 1/8 come through this. Then g of x will be log of 1/8 to the base 2, which is -3. As far as g is concerned, no problem. It will allow 1/8 to pass through. But the problem comes when f is taking f -3 - 1, because f is root of x - 1. And therefore, this will not be allowed. Right? Are you guys with me? Okay, so what are we saying in conclusion? We are saying there are two restrictions to determine what the domain of f of g of x is. The first restriction is it has to be, first of all, look at the domain of G. Okay, but within that, only those where G of X is a valid input to F. Okay, does it make sense? Okay. Sarah, does it make sense to you? You're good? Okay, right. So if I'm looking at F here, so what will F take? F will take any value which is greater than or equal to 1, which means G of X, the output coming here, that should be greater than or equal to 1. Only then it can pass through the next step, which means what? Your log of X to the base 2, which is what your G function is, must be greater than or equal to 1. Which means what? X must be greater than or equal to 2. Because 2 power 1 is 2, right? As long as X is greater than or equal to 2, now we have restricted our domain C. For G, the domain was X greater than 0. Whereas for F of G of X, the new domain has become X should be greater than or equal to 2. Only if X is greater than or equal to 2, the output from G is greater than or equal to 1, and hence can be passed as an input to F. Okay. Same idea for the reverse case also. Suppose I do G of F of X. Sumer, does all this make sense to you?
Yes, sir.
Completely, right? It's just logical. You don't have to think anything. It's just logical, right? Okay, so let's do G of F of X. So G of F of X, I'll do it in a different color. Okay, actually, do we have enough space? Yeah. So G of F of X, right? What is my G? I forgot. G is log X to the base 2, right? But first X passes through F. And then your F of X comes. And then this gets passed through G. This is your G. And then since the input to G is F of X, the output here is G of F of X. Now this whole thing is a block which can be called G of F of X. Okay, so same thing. So in this case, F is root of X minus 1. So the domain for F is X is greater than or equal to 1. Okay, now what is G? G is saying log of X to the base 2, right? So if will every number greater than 1 be allowed? So if F takes a number which is greater than or equal to 1, let's say F takes, I don't know, 1.2, right? So F of 1.2 would be how much? Root of 1.2 minus 1, which is square root of 0.2, which is a positive quantity, right? Can G take that positive quantity? Yes, of course it can. So as long as the output F of X is positive, it's a valid input for G of X, right? And in this case, since F is square root of X minus 1, the output of square root of X minus 1 will always be positive, and therefore there is no problem at all, except just an edge case. Suppose X is equal to 1, then there's a problem. If X is exactly equal to 1, F will still take it because root of X minus 1 is still allowed. Root of 0 is 0. There's no problem there. But the 0 cannot be fed in as an input to G because log of 0 is not allowed. And therefore, the final domain for G of F of X becomes, the domain is X should be strictly greater than 1. It's not enough if X is greater than or equal to 1, but X must be strictly greater than 1. So the idea is very, very simple. You look at the first block that X is going to pass through. In this second example, it's F. First of all, the domain will at best will be that much. It has to be restricted. It can be at best the entire domain of the first function, in this case F, or it could be a smaller collection than that. Why will it be a smaller collection? Because some of the outputs resulting from the first block may not be valid inputs for the second block. That's all there is, right? Simply thinking of it. Okay, sounds good. Keshav, you're with me completely, right, on all of this?
Yes.
Okay. Now the third part is not third part, in the sequence of things we are looking, something called inverse of a function. Inverse of a function. So inverse of a function is, we say G is an inverse of F. If F of G of X is back to X, right? Just like the plain word English, right? Whatever F does, G undoes it, right? Undoes it or undoes it. Okay, undoes it, right? So it'll set it back to what the original input was. So such a G, so if F of G of X equal to X, then G is called the inverse of X. Inverse of X. Inverse of F, I'm sorry. Inverse of F. And it's denoted by F power minus 1 of X. Right? So it's not to be confused as the reciprocal of F of X. This is not 1 over X, 1 over F of X. Right? It's tempting to write it, think of it that way. It is not. Right? It's F inverse of X. It's not the reciprocal of F of X. Reciprocal of F of X is something else. It could be another function. I can define a function H of X, which is reciprocal of F of X. But inverse is different. This is different. And in some strange cases, they might be coincident as well. They might be the same also. But in general, these are two different things. Now, how do we find F inverse of X? Let's take one simple example, right? For a simple example, like F of X equal to 2X, we can even guess. What will the inverse be? It will be X by 2. Because if you are doubling, what is the operation that will set it back? Halving will set it back. Therefore, the inverse is X by 2. If F of X is X plus 7, the inverse will be X minus 7. Because if X passes through F, it becomes X plus 7. If that passes through a function which subtracts 7, you get back X. So for very obvious functions like this, inverse of doubling is halving, inverse of adding is subtracting. But suppose you have a more complicated expression, right? Suppose F of X is 2X plus 3. Even here, we can find the inverse very easily, right? So to undo what you did, right? Just think logically what I'm doing. You're doubling a number and then adding 3. If you have to reset it back, you retrace. You subtract 3, right? You subtract 3, right? Okay, let's say this is your X that's you're operating on. You subtract 3 and then you divide by 2. Does it make sense? Doubling, adding 3. If you want to retrace, you subtract 3 and then half it. And then you get back your inverse, right? But if it's getting little intertwined, then it becomes difficult. So for example, suppose F of X is 2X plus 3 upon X minus 1. Then we are in a soup. Then it's all intertwined, right? How do you retrace this? So you double and then add 3. And then now comes divide by what? You've already operated on X already. You've doubled it. You've made increase it by 3. So there's no proper way. Now, how do we find inverse of such a thing? So there's a standard method for it. I'll just write, this is Y, right? So Y equal to 2X plus 3 by X minus 1. You swap your X and Y. So at the very beginning, you swap your X and Y. You write X equal to 2Y plus 3 by Y minus 1. And then you solve for Y in terms of X. Right now it's X in terms of Y. So let's cross multiply. XY minus X equal to 2Y plus 3. Now to solve for Y in terms of X, what would you do? You will collect all the Y terms to one side. So let me bring the 2Y to this side and let me send the minus X to this side. So it's X plus 3 here. On the left hand side, it's XY minus 2Y. So it's Y times X minus 2. Therefore, Y is X plus 3 by X minus 2. Okay, so this is my inverse. So this is my F inverse of X. Okay, always good to check. So let's check one simple example. Suppose my input is, so we have to go back here and check, right? Suppose my X is, I'll take some simple example like the 2, right? So what is my F of X? F of X is 2 times 2 plus 3, which is 7, upon 2 minus 1, which is 1, which is 7. Okay, so this is my F of X is 7. Now, the way I want to check is, suppose I feed in 7 in the F inverse of X. In the F inverse of X, suppose I feed in 7, I must get back my original input, which is 2. Do I get that? Let's see, 7 plus 3 by 7 minus 2, because X plus 3 by X minus 2, which is 10 by 2, which is, sorry, 10 by 5, which is 2, which is exactly the input I started with. So it passes that check, right? Of course, you have to try this for infinite values of x to be sure you're right. But as a simple check, 1 or 2 values, if we check and does make it tallies, then we are good. Makes sense. Moksh, question.
So firstly, if the initial f of x is a many-to-one function, then f inverse of x won't exist. So how will you know when f inverse of x exists and when it won't?
Good question. Yeah. So yeah, the existence of, we can still calculate f inverse of x, but does it make sense? As you rightly said, if f of x is not a function, the whole point of f
No,
inverse
sir.
of x.
If f of x is a many-to-one function, that still counts as a function. But
Yeah.
f inverse of x won't be a function because it's one-to-many.
That's correct. All I'm saying is it's f inverse of x. I'm not saying f inverse is a function. It's an inverse of this original function, but f inverse itself need not be a function,
Okay.
right?
One thing, for this question specifically, please scroll up, please.
Okay, just one second. I want to just highlight a point he made. What he's saying is, he's saying is, so suppose my f is turning out to be a function like this. So this is my f of x. My f inverse of x, if you look at it, it'll be like this, more or less, right? Your x and y are swapped, right? You're mapping the output to the input. That's what f inverse is. Now he's saying in this example like this, like a sinusoid, f of x is a function, but f inverse of x is not a function. You can still find f inverse of x, but it's not a function. It's a relation, because for one value, one input value, you have multiple output values. Because the original f was like that. For multiple different inputs, you had one output, which is why the tables are flipped now. In f inverse, we are seeing that for one input, there are multiple outputs, right? Long story short, if f of x is a many-to-one function, then f inverse will be a relation. It will be a one-to-many relation. It won't be a function. On the other hand, suppose f is like uniform like this or something, right? Then f inverse will also tend to be some shape like this, right? Or it might be this way, whatever, but it'll be uniformly increasing or uniformly decreasing, in which case both f and f inverse are functions. Okay, Moksh, your follow-up question.
One more thing. Just want to clarify. I think it's true, but I'm not sure. If g of x is f inverse of x, then f of g of x, g of f of x is x, right?
Correct. So
is f of g of x also x?
f of g inverse is x. Sorry, f of g is x. G of f is also x.
Okay.
What is the other thing you asked?
That was it. And one last thing. For this question, could you scroll up to the question?
Okay.
Couldn't you express it like as a mixed fraction with y minus 1 in the denominator?
Say that again once more.
Couldn't you express it as a mixed fraction? Divide 2y plus 3 by y minus 1 and get the remainder as that remainder is 1y minus 1.
Yeah, whatever way you can simplify. Doesn't have to be that you have to cross multiply. You can do a mixed fraction and then simplify from there. That's fine too. Yeah. Moksh, okay? Okay, all right. So actually, so just to clarify what he asked, so two things he asked, right? So if f of g of x equal to x, that means I said g is the inverse of x, right? Then in that case, g of f of x will also be x. The moment g is the inverse of f, automatically f becomes the inverse of g, right? Okay, so the other point he asked was to simplify this. Can't I actually divide it? So I can actually do that. So what he's saying is, if I divide 2y plus 3 by y minus 1, right? So if I actually divide, it becomes 2y minus 2, right? So the remainder is 5, I believe, right? So you're saying x is 2 plus a remainder of 5, right? So 5 by y minus 1, right? Now x minus 2 becomes 5 by y minus 1. So which means y minus 1, how do I simplify this? Y minus 1 by 5 equal to 1 by x minus 2, I guess, right? Right, now I can bring the 1 by 5 and add 1 by 5 plus 1 by x minus 2. Am I right, or am I doing something wrong? No, sorry, no, I just have to multiply by 5, right? Just have to multiply by 5 and then solve for. So 5 by x minus 2 equal to y minus 1. I can bring the 1 to this side. So it becomes 5 by x minus 2 plus 1, which means x minus 2, 5 plus x minus 2, which is the same, x plus 3 by x minus 2. Is this what you're trying to say, Moksh? Solving it this way?
Yeah, that's what I was trying to
Yeah.
say.
Either way, whatever way you solve, you should still get the same value for the inverse. Okay, anyone else? Sumair, all good so far? Okay. So what did, I'm just going through what all is left to be covered. If you look at function, domain, range, composite function. Sorry, let me just look at the portions here. Domain, range, composite, inverse. Okay. Before we go to transformation of functions, I want to do a few examples in functions, right? So let's do some practice problems. Okay, I haven't shown you sketching functions, but we'll do that as we go through. Just allow me 1 second. Let me just find the question set here. Generated functions. Okay, so let's start with. Okay, can we do this? So there are different ways of representing a function. So you'll see representations like this. Once you see, you'll be able to figure out what they mean, right? So f colon, right? F is a mapping from x to some expression in x. So this is another fancy way of writing f of x is x plus 10 by x minus 8. That's all there is. X plus 10 by x minus 8. Okay, now can we do this one, guys? I'll give you some time. Maybe a minute. Find the domain and the range. He didn't ask for a domain, but I'm asking you what the domain is. Oh, actually, he has given the
So they
domain in the
gave the
question.
domain.
Yeah, he's given the domain. He has given the domain is x need not be greater than or equal to 0. For example, x could be -3 also. But he is defining the problem. The problem main based on his own will. Even though if you look at x plus 10 by x minus 8 as such, the obvious thing that x cannot be is 8. But x can be anything else other than 8. But the problem setter might enforce a certain condition, further condition, x greater than or equal to 0. That's his own way of defining what is the set of x values he wants to consider for this problem. Okay, so the domain is fixed. Determine the range. Okay, Sarah, you want to take this? What is the range?
Any value? Is it like negative infinity to positive infinity?
Okay, can you justify that? Why is it any value?
So I know the range x cannot be 8. So x plus 10 over x minus 8, if x is not 8, can be any value, and same
Okay.
for
Okay, so when will it be -1, for example? For what value of x will it become -1?
where can I check?
Yeah, you can check, yes.
Y can't be equal to 1, right?
Y can't be equal to 1 because x plus 10 will always be bigger than x minus 8. That's right. Yeah. So, yes, which is why it's important to learn how to plot a function, which I was going to come to next as part of this problem itself. So you are right that y can be anything, because the only restriction that you don't want is 8. But on either side of 8, you can wiggle around x to be 8.001 or x equal to 7.999, making the denominator as close to 0 as possible. which means you have the full coverage going from plus infinity to minus infinity, right? The only possible value that's not allowed is x plus 10 will never equal to x minus 8. And therefore, the expression itself will never be equal to 1. Okay, but how do we approach this in a more systematic manner? And how do we say y equal to 1 is not possible? So let me just...
So one thing though.
Yes.
Really use this logic, because you can use this logic to justify how the function can tend to positive or negative infinity, but x has to be greater than 0, so you can't have more smaller values. Like you can have big values, sure, but you can't have smaller values because of the second restriction.
Smaller values for x, you mean?
For f of x, because like you said, you can't have f of x equals to -1. For that, you would need x to be -1, and that's not allowed because that's out of domain.
Okay, so basically you're saying the denominator, in this case, at the smallest value of the denominator is -8. It won't go beyond -8. That's what you're saying.
Yeah.
Okay.
That
Yeah.
limits.
Yeah, point noted. Okay, let's try to sketch this function, right? So how do we go about sketching any function? So there are a few things. So the first thing is, I'll come to Moksha, good point, but I'll come to it. Okay, so in sketching, oh gosh, the first thing is, what is your x-intercept? What is your y-intercept? And then what happens when x goes to infinity? What happens when does so this is also called your horizontal asymptote. Horizontal asymptote. Asymptote is a behavior towards infinity. It can be in the x direction or the y direction. Okay, and then when does y tend to infinity or minus infinity? Okay, so for now I'm just roughly writing all this. Let's go through each one of them separately, right? So what does x-intercept mean? When x is 0, what is the value for y? So in this case, let's blindly put 0. 0 plus 10 upon 0 minus 8, which is -5/4. Okay, so let's plot somewhere -5/4 somewhere here. Okay, that's the x-intercept. What is the y-intercept? What value of x will cause the y to be 0? That's what the y-intercept is. Sorry, I mixed up the two. What we first did is the y-intercept, right? For x equal to 0, where does it cut the y-axis? That's the y-intercept. So when x is 0, it passes through y equal to -5/4. The x-intercept is the reverse, right? Where does it cut the x-axis? Meaning, when does the y value become equal to 0? In other words, when does the numerator become equal to 0? So in this case, the numerator is 0 when x is -10. So it passes through -10, 0. So the graph passes through these 2 points. Okay. Now, when does the y value approach infinity or negative infinity? When the denominator is very close to 0. The denominator is close to 0 when x equal to 8, right? Although x equal to 8 is forbidden, let's say this is x equal to 8. Okay, so x equal to 8 is forbidden. So like a wall here, right? It's called a vertical asymptote. Okay, so it's a vertical line, hence the vertical, and it's an asymptote, meaning you cannot reach that, but you'll get as close to that as possible. So what do I mean by that? Suppose x is 8.0001 something, right? Then the numerator is practically 18, whether it's 18 or 18.001 does not matter. But the denominator is a small positive quantity, which means the ratio is going to be a huge positive quantity, 18 upon 0.0001, which is like 18 million or 18 zillion, whatever, right? In reality, right, as close to infinity as possible. So this graph will go as much to infinity as possible, right? And on the other side, suppose x has become slightly less than 8. Let's say x is 7.9999, right? Then the denominator is slightly less than 0, so -0.001. The numerator is practically still 18, whether it's 17.999 or 18 or 18.001, doesn't matter. But the denominator is swung to the other side of 0, taking the entire fraction to negative infinity. So the graph is going to approach negative infinity but never touch negative infinity, hence the term asymptote. So this is a vertical asymptote. You'll block, you cannot reach that, but that's the wall towards which you are tending towards. Okay, so we have covered as for what value of x will the denominator approach 0, causing your y to approach infinity or negative infinity. The last part is what is the behavior of the graph when x itself tends to positive infinity or x itself tends to negative infinity, both of them, right? I'll put plus or minus here. So when x is a large positive quantity, let's say x is a million, right? So million plus 10, right? Upon a million minus 8. So whatever, let's say 9999992 or something, right? But practically these two quantities are effectively the same, except the numerator slightly more than the denominator. Do you agree? It's a millionaire having an extra $10 or losing $8. Practically, he's going to be as wealthy as he was before, right? So the ratio is approaching 1, but slightly more than 1, right? You can see the ratio is more than 1. So which is why you draw horizontal asymptote at 1. And you say that as x approaches infinity, this graph will approach 1, but it will stay above 1. So this is the horizontal asymptote y equal to 1. And this is the vertical asymptote x equal to 8. Right, I'll erase all this x equal to 7.999, all this business. So this is the horizontal, right? So the vertical asymptote is x equal to 8. The horizontal asymptote is y equal to 1. Now we can connect the missing pieces like a puzzle, right? So for it to be a smooth graph, this is going to gradually reduce and then approach the horizontal asymptote for large values of x. And similarly, on this side is this side. Suppose x is a minus million. So if you're down a million, whether you have an extra $10 or whether you have an extra short of $8, doesn't matter. You're going to be more or less the same. But in this case, numerically, the numerator is smaller than the denominator. It's like minus 999990 upon minus 10008, something like this, right? It's a fraction slightly less than 1, right? But it's a positive fraction. Negative upon negative is positive. So that's what is going to happen on the negative side also. The horizontal asymptote is y equal to 1, but it'll approach it from this way because it's heading towards 0.9999999, right? And now we can connect the missing pieces. So it passes through this, it passes through this point we know, and then the graph goes like this. Right? And now back to what Keshav was saying, if you look at the domain is clear, x is not equal to 8. Okay, I'll come back to Moksha's question, right? Suppose the domain did not have the further restriction that x is greater than or equal to 0, which I missed. Okay, and thanks for pointing that, Moksha. Suppose x is greater than or equal to 0, it's not there, right? It need not be there, right? The only stumbling block is x equal to 8. As long as x is not equal to 8, we are fine. So for the case that x is not equal to 8, the range would be all values of y except y equal to 1, because we can see that it never approaches 1. Are you guys with me? But for this case, right, x is given to be strictly greater than or equal to 0. Not strictly, it's greater than or equal to 0. It's given to be greater than or equal to 0, right? So which means the range will also get restricted, which means we have to wipe out from our diagram anything that we have drawn to the left of x equal to 0. So all of this doesn't even come into the picture because he is saying the problem is defined only from x greater than or equal to 0, which means the range also gets restricted as a result of that. Good point, Moksh. Good catch on that one. Does it make sense, guys, to everyone? Sarah, does it make sense?
Yeah.
Okay, the question itself need not have specified x greater than or equal to 0, but because they have specified x equal to greater than or equal to 0, we have to respect that, right? Therefore, the range gets restricted. It's not just minus infinity to infinity. Now we know that on the positive side, it can go all the way from positive infinity all the way down to 1, but not equal to 1. And then coming on this side, what is this point? We saw, right? 0, how much was this? Minus 5/4. Minus 5/4. Right? So on the negative side, it can go from minus 5/4 all the way till negative infinity. So the range would be So I would say the range is minus infinity less than y less than minus y by 4. Okay, so this set union, because union u, the set which starts from 1 less than y less than infinity. So the range is a collection of these points. On the positive side, anything above 1 all the way till infinity. On the negative side, minus 5 by 4 less than or equal to. Should be very careful where you put less than or equal to, where you put less than, because x equal to 0 was still valid, which means you can achieve y equal to minus 5 by 4. Are you guys completely, Avi, are you with me completely? Dave, all good? Okay. And then, so it's always important to learn how to sketch a graph, right? Sketching will automatically answer what the domain and range is completely, right? So, and the second part, find the value of a such that f of a equal to a, that's fairly easy, right? So a equal to, we can just do it together, a plus 10 upon a minus 8. So we can cross multiply. So a square minus 8a equal to a plus 10, which means a square minus 9a minus 10 equal to 0. I can simplify this as a minus 10 times a plus 1 equal to 0, which means a equal to 10 or a equal to minus 1. But the input a cannot be less than 0 because the question itself says I must be greater than or equal to 0, right? So the input to f cannot be greater than, cannot be less than 0. Therefore, the only possible value is a equal to 10, right? And graphically also, does it make sense? So why do we get two answers, 10 and minus 1? Suppose the original question did not have the restriction that x is greater than or equal to 0. Then we are asking, when is the function f of a same as a itself? Meaning, think of two functions. One is the function f of a, the other is the function a itself. Meaning what? You're comparing it to the function y equal to x. So this is like y equal to f of x, right? And this is your y equal to x. Where are the two functions meeting? If you look at when are the two functions meeting, how will y equal to x look like? It look like a 45-degree line, right? So that line will look something like this. On this side also, y equal to x. Right, I didn't draw it well, which is why you're seeing two intersection points. This is your minus 1, which we know now that we are not supposed to include. And this is the 10 that we saw. So at 10, the value is also 10. 20 by 10 plus 10 by 10 minus 8 is indeed 10. And at minus 1, suppose we are allowed minus 1, then it will become minus 1 plus 10, which is plus 9, by minus 1 minus 8, which is minus 9, which is the minus 1. So minus 1 comma minus 1 is also a point, if only we were allowed of including the domain which is less than 0. But in this case, it's not. And therefore, only a equal to 10. Was there a question? In between, I thought someone had a question. No? All good? Okay. Okay. Sorry, guys. How are we doing with time? Okay, we have about 10 more minutes, right? So, sorry, I didn't intend to stop share. Okay, so let's do more questions. Absolute value function. Okay, all right. So let's practice absolute value functions. We won't do all of them, but we'll pick one or two, right? So can we do maybe question B? Sketch the graph of the following function, mod of 2x minus x square. Can you try it? How this function will look like? By hand. Sketch, it says, not plot. So you're not using a calculator, but just with pen paper, you're supposed to sketch. Okay, Sumer, how will this look like?
Just give me half a second. I'm just
Half a second.
so obviously it'll go to infinite, because if you take x,
Yeah.
if you take x to be infinite, then because infinite square will be a humongous value.
Yeah, correct. Yeah. You can even annotate and show if it's easy for you. You can just I've drawn the x-axis for you. Yeah.
Sure, so I'll try it. This is for the y-axis, right?
Yeah.
So one sec, I forgot to calculate the the x-intercept.
Okay.
X minus x squared is equal to 0. Yeah, okay, that was stupid. So the x-intercept is just 4. So I'm just gonna
4 how?
oh sorry, 2, my bad.
2. Okay.
So let's just say this is 2. So so the values for x, the input can never be negative, obviously.
Why cannot the input be negative?
The output, like y
Yeah.
can like it can't be in this region, right?
It cannot be below the x-axis. Correct.
Yeah.
You're right.
So but x could be any value, right?
Correct.
And if x is wait, is there only one x intercept?
You tell me.
X minus x. There should be a one on the negative side. Then it'll be a positive value. Oh yeah. Yeah, okay, wait 1 sec, sir. Let me
Yeah, sure.
it's going up here. Wait, I drew it a little lower, but like wait, the drawing is not the best. I think it'll be something like this. But obviously it's not gonna go below the x line. Wait, so once.
Yeah, what I suggest you do is ignore the absolute value. Just plot y equal to 2x minus x square. So let's do that first. So 1 sec, Sumer, I'll just take it from you. Okay, so just plot. How do I erase your drawing? I'm not able to erase that. Can you erase your drawing? I'm able to erase mine, but not yours. Okay, so let's plot y equal to 2x minus x square first, right? Which is just a simple quadratic. I can write as minus x square plus 2x, which means it's 0. So if I factorize this, what happens? It's minus x times x minus 2. So, or rather, if I have to write it as minus of x minus 0 times x minus 2. So the other value that you were searching was 0 itself. So this quadratic, right? This quadratic function. Why am I not able to draw this? Right? This quadratic function has two intercepts, x equal to 0 and x equal to 2, right? So, and then it'll reach a peak value at x equal to 1. And it's a downward going parabola. Right? So this is without the modulus. Now with the modulus, all we have to do is the portion which is less than 0, the y value is less than 0, gets reflected upwards, right? So the portion which is here, which is on the bottom, got reflected. The portion which was below here also got reflected up. Right? Not this way, but this way. The portion which is 0 below this got, so this will go all the way till infinity, like you said. Does it make sense?
Yeah.
Okay. Yeah, I'll give more practice problems. I want to do some variety of questions. Let's do. Dave, can we do? Find the range of these following relationships. I'll give you this last one, H1. Can you find the range of this? 2a by square root of a square minus x. Actually, first answer what the domain should be. It's not given the domain. So let's do domain and then we'll do the range.
So when you solve this, are you expected to give the range in terms of A?
Correct. You're supposed to give the domain range in terms of A. Okay, so first the domain, Dev.
Okay. I don't know, I'm sorry.
Okay. Okay, in the interest of time, let's quickly do it together, right? So think of it like a number, right? For example, A is less than 0 is given. So instead of A, just put -3, just so that it's easy for you. And then we can work it out more generally. So instead of A, all I'm doing is putting -3 just to help me, that's all, right? So this would have been the problem had A been -3. Do you agree?
Yeah.
So this is what square root of 9 minus x. And this
Yeah.
numerator is just -6, just a number, right? So
Mm.
the domain for this would be as long as x is less than 9. In fact, as long as
Yeah.
x is less than or equal to 9, we can do the root. But if x equal to 9, then we can do the root, but we get a 0 in the denominator.
Yeah,
We don't
it'll
want that,
be
right? Therefore, x is less than 9 will solve the problem of the root as well as the denominator. So we just translate it in terms of x is less than a square. Where did it get the 9 from? It was because it was -3 whole square. So that makes sense, right? As
Okay.
long as x is less than a square, the denominator is a square root of a positive quantity, which is valid.
Yeah.
Okay. And now comes the range, right? So this denominator we know is a positive quantity, but as close to 0 as possible. But there's no restriction how close to 0. Correct? So as x nears a square, it can be very, very tinily close, right? It can get very, very close, right? And as x becomes less than, substantially less than a square, the denominator can go all the way till infinity. Correct?
Yeah.
Right? But the numerator is a negative quantity. 2a is a negative quantity, right? For different values of a, it's going to be it's a negative quantity because a is given to be less than 0. Right?
Yeah.
Which means it's a negative numerator upon a positive denominator, and the denominator can be as close to 0 and as high as infinity, which means we're going to cover all possible negative values for the fraction itself, right? So y will take any value which is less than 0. But of course, you won't hit 0 because a cannot be 0. A is given to be less than 0.
Yeah.
And then all the way till -infinity. How can it be -infinity? As we just said, as x is approaching a square, this will approach -infinity.
Okay.
Does it make sense? So for example, in this problem itself, -6 by 9 minus x. Suppose x is 8.9999. Then the denominator is 0.000001. So which means it's -6 million, which means -infinity.
Yeah.
Does it make sense? On the other hand, x can be less than 9. It can be, for example, -1 trillion, right? X can be -10^12. No problem there at all. Which means the denominator will become a huge positive quantity. And right, the numerator is
a very small negative quantity, like give me -0.00.
Correct.
Who knows how many?
Correct. Yeah. So a is given to be -3 in this example, right? Therefore, it's approaching 0. Okay. All right. So we're up on time. Okay, let's continue tomorrow. We have to do some more concepts and functions, remainder theorem, factor theorem, expanding the sum and product of roots for polynomials. And then plotting other types of functions like exponential function, logarithmic function, all of that. So we have some ground to cover tomorrow, but we'll be done tomorrow. Okay. Any questions before we wrap? Functions is a bit of a vague topic, so bear with me for some time. Yeah.
I've got one question, but it's not
Yes.
really in syllabus.
Okay, then we can park it for later, or you can message me separately.
Okay, sir.
Okay.
Yeah.
All right. Anyone else? Any questions before we wind up? Keshav, all good?
Yeah.
Okay, cool. Thank you guys. Bye.